EV12AQ600 is the first 12-bit C-band ADC to feature a quad-cores microwave crosspoint switch. Its 4 cores can operate simultaneously, independently, paired or all interleaved to assign its 6.4 gigasample per second sampling speed. With a choice of various reliability grades, including a radiation-tolerant and QMLY space-qualified version, AQ600 ADC is an ideal companion to the microchip radiation-tolerant FPGA PolarFire. Extensive testing has confirmed radiation tolerance of EasyStream serial interface used to transmit samples. And a link to heavy ion radiation report is available in description of this video. So, this ADC offers exceptional on-the-fly configuration possibilities to design space receivers from L to C-band. Now I'm going to show you all the steps required to start receiving samples using a PolarFire FPGA, and how you can gain weeks of development times following this tutorial. For this tutorial, we will use the FPGA carrier board MPF300 video kit, the AQ600 FMC board, and 2 SMA100A signal generators. One to generate the ADC input clock at 5 GHz, and the other to generate the ADC input signal. Here is a quick overview of the FPGA design example. AQ600 ADC and EasyStream samples receiver module in the FPGA are configured using UART and a Python graphical user interface. Samples are acquired using the Identify Debugger feature of the PolarFire FPGA, and then samples are analyzed in frequency domain to display the ADC analog input spectrum. Now, let's start this tutorial. First, you must download the design example package. On easystream.com, click on Package, then on Start your EasyStream project using an existing package, and scroll down until you find the Microchip FPGA and AQ600 package. Click on the Download button and unzip it in your work directory. Now we have downloaded the package, we can generate a design example project using Libero 2022.1. Click on Project and execute script and look for available tickle script. Select the script and click on Run. Once project generation is complete, you have first to click on Synthesize. When this step is completed, let's select all signals we need to acquire ADC samples using Identify Debugger later in this tutorial. Right-click on Synthesize and on Open Interactively. In Simplify Pro, right-click on Synthesis and click on New Identify Implementation. Then open this new implementation using Identify Instrumentor. In File Browser, click on Frame Checking module. Here you can select the sample clock and ADC samples to acquired. You also need a trigger. Click on Top File and select the EasyStream synchronization signal as trigger. Then click on Edit IICE to change sample depth to 1024. Now you have selected debug signals, you can save the project and synthesize the new implementation clicking on Run. Finally, you can generate the FPGA bitstream. It takes approximately half an hour to complete. Now we have generated the bitstream, we are ready to load it in the FPGA. First, power on the FPGA carrier board. And in Libero, click on Run Program Action. Now we have programmed the FPGA, we can power on the ADC board and the ADC clock. The hardware setup is now complete. We can launch the graphical user interface using a Python script. To do so, open a command window in package folder Python and type python GUI.py com plus the ID of the compor. You can find the ID of the compor in the device manager. For this demo, I configure the ADC in one-channel mode and a sampling frequency of 5 gigasamples per second. This is the default configuration. The ADC embeds a useful feature, the ramp test mode. In this mode, a known pattern is sent through the serial interface, and so we can check that the EasyStream serial link is working properly without any communication error. So let's look at how all of that works. First, select the ADC external clock. Then reset the ADC and load OTP registers. Select the ramp test mode and configure the ADC selected modes. Finally, you can synchronize the EasyStream serial link. At this stage, the FPGA starts receiving samples from the ADC. In ramp test mode, the FPGA carrier board LED 4 indicates that there is no communication error if it remains off. Going back to Libero, we can now acquire sample data using Identify Debugger. Click on Run to start an acquisition. In Python Graphical User Interface, you can display the sample spectrum clicking on Plot Data. And here we can see a spectrum of a ramp pattern. Now we have seen that the EasyStream serial interface is working properly, we can acquire a real signal on ADC input 0. Now I configured the SMA100A signal generator to generate a coherent continuous waveform at 1.5 GHz. Going back to the graphical user interface, I now configure the ADC in normal mode with the appropriate calibration set. Then I restart a new acquisition. And we can now display the data. We can see we have an SFDR of 55 dBc at an SFSR of -8 dBFS. Finally, I configured the SMA100A signal generator to generate a coherent continuous waveform at 4.3 GHz, and we have an SFDR of 42.8 dBc with an SFSR of -12 dBFS. This brings us to the end of this tutorial. You have learned how to get started with EV12AQ600 ADC and PolarFire FPGA. And so you can see how this will help you to gain precious time in your development. Plus, the EasyStream license is free of charge and open source, so you can modify them as necessary. All the useful links are available in the description of this video. And if you have any question or if you need support, please contact us using Teledyne hotline email address. Thanks for watching.